In this video, we are going to talk about how to construct a polynomial using forward differences method. And this method is also called Gregory-Newton forward interpolation method. So we will solve a problem here. We have 3 points data given 2, 4, 6, -1, 3, 9 in the form of xy values. And we have to construct the polynomial by using forward differences method. And then we have to find f of 3. Since we have 3 points data given, and we can see that this data is equally spaced because we have 2, 4, 6 and y values are -1, 3, 9. To see that if your data is equally spaced or not, you don't have to look at y values, but see that the difference between every two consecutive x values is same. So we can see that 4 minus 2 is 2, 6 minus 4 is 2. So the difference between x values, every two consecutive x values is same, which is here 2. So yes, our data is equally spaced. Okay, to construct the polynomial using the 3 data points, we first write the Newton's polynomial, which involves A's polynomial coefficients, Newton's polynomial coefficients. So for the 3 points data, the maximum degree of Newton's polynomial is 2. So we write P2 of x. So we are going to write Newton's polynomial first, which is A0 plus A1 x minus x0 plus A2 x minus x0 x minus x1. Now let's write this Newton's polynomial in forward difference operator form. So we have to put A0, A1, A2 in forward difference notation. We know that A0 in forward difference notation is just y0. A1 is forward operator y0 over h, and A2 is forward square y0 over h power 2 factorial. Let's plug A0, A1, A2 in forward difference notation in the polynomial. So we have P2 of x equal to y0 plus forward y0 over h x minus x0 plus A2, which is forward square y0 over h square 2 factorial into x minus x0 into x minus x1. So this is the Newton's polynomial in forward differences notation. Now what we are going to do is we have to plug in the differences, forward differences values and x values here in this polynomial on the right hand side. So for this we will construct forward difference table. So we have the x values 2, 4, 6 and y values -1, 3, 9. Let's calculate the differences. Arrow between -1 and 3, so you calculate 3 minus -1, which is 4. Arrow between 3 and 9, so you calculate 9 minus 3, which is 6. Arrow between 4 and 6, so you calculate 6 minus 4, which is 2. We have calculated the differences, but let's name this data. x0, x1, x2, y0, y1, y2. The third column is named forward yk column and the fourth column is named forward square yk. We can write here 4 as forward y0. It's the notation for this difference. Next value in this forward yk column is forward y1. And in forward square yk column, the value 6 minus 4, which is 2, is named as forward square y0. So we have constructed a forward differences table and we have also named the values in this table. So now let's plug these values from the table in this polynomial P2 of x. So we have the polynomial P2 of x is y0 plus del y0 over h x minus x0 plus del 2y0 over h square 2 factorial x minus x0 x minus x1. So P2 of x can also be written as just the function f of x, which can also be written as y, equal to y0 here is -1 plus Del y naught from the table, in the third column, the first value del y naught is 4. 4 by h. H is the consecutive difference between every two x values. So here it is 2. Because 4 minus 2 was 2, 6 minus 4 was 2. X minus x naught here is 2 plus del 2 y naught from the table, in the fourth column, the first value and the only value is del 2 y naught is 2. 2 over h is 2, h square, 2 factorial is 2, x minus x naught is 2 into x minus x1 is 4. So we got the polynomial. Let's simplify this. So we have minus 1 plus 2 x minus 2 plus 1 over 4 x minus 2 x minus 4. So this is how we construct the polynomial by using forward differences method, or it's also called Gregory-Newton forward interpolation method. So after constructing the polynomial, we can verify that if this polynomial is correct. So our data values are, x values are 2, 4, 6 and y values are minus 1, 3, 9. So for every given x value, we should be getting the given y value. For example, in the data, for x equal to 2, your answer for y is minus 1. So in the polynomial, when you plug in the place of x as 2, you should be getting minus 1 for y value. So let's do that. Minus 1 plus 2, in the place of x you plug 2, 2 minus 2 plus 1 over 4, 2 minus 2, 2 minus 4. So this becomes 0 because of 2 minus 2, which is 0. This also becomes 0. So you have P2 polynomial. At x equal to 2, you got minus 1, which should have been so because the data says for x value 2, your answer for y is minus 1. The same way you can check that when you plug x equal to 4, you should be getting y 3. The same way when you plug x equal to 6, you should be getting 9. So this is the verification part. So the polynomial here is y equal to P2 of x, or it's same as f of x equal to minus 1 plus 2x minus 2 plus 1 over 4 x minus 2 x minus 4. Let's look at the question that we had to construct the polynomial by using the forward differences method, and after constructing the polynomial we had to find the value of the function at x equal to 3, f of 3. So to find f of 3 means the value of function at x equal to 3 in this polynomial, we will put x equal to 3 minus 1 plus 2, 3 minus 2 plus 1 over 4, 3 minus 2, 3 minus 4. We will simplify. Minus 1 plus 2, 3 minus 2 is 1 plus 1 over 4, 3 minus 2 is 1, 3 minus 4 is minus 1. So we have minus 1 plus 2 minus 1 over 4. So we have f of 3 by 4. So this is how we construct the polynomial from the given data using the forward differences method, which is also called Gregory-Newton forward interpolation method, and then we find the value of the function at given x, and here the x was 3, so we found f of 3. In the next video we are going to talk about how to construct the polynomial using the backward differences method.